The wooden track layout. Reverse merge. Wooden tracks, electric trains. By Gary Schick. November 2025. Here, we continue the Wooden Tracks Electric Trains episode, the reverse merge, at part 3. In this 4-part episode, we explore the nature of the merged tracks and how these components are used in construction of interesting track layouts. Previously, in the reverse merge part 1, we discussed the difference between a merge and a switch component and used a reversing loop to demonstrate several concepts related to the reverse merge. In the reverse merge part 2, we analyzed the configuration of 2 adjacent merge tracks we call an inverse merge crossing. If our terminology is unclear, or you do not remember where a merge entrance or exit is found, you should first watch or re-watch the initial video in this episode titled Reverse Merge Part 1. Here, in Reverse Merge Part 3, the bypass, we will demonstrate another way that merge tracks are used in our complex layouts. As the name implies, a bypass is a method of diverting the path of an engine or a train a short distance to avoid a problematic area in a layout. This need for a bypass typically arises when a train is allowed to travel a section of track in 2 directions, but there's an obstacle in that track section, such as a switch exit, a problematic crossing or intersection, or an oncoming train. In the previous episode, in the challenge question, we said that we want to have an option to reroute the blue engine so that it would use more of the same path in both travel direction. In other words, we want to change the path of the blue engine slightly, so that when traveling in one of the directions, each path has more in common with the other. At the same time, we would like to be able to keep the existing routes, if possible. In this layout, the section of track in common when the blue engine travels in opposite directions exists between IC4 and ME1. In the previous episode, we asked you to visualize how to increase the amount of common path without eliminating the possibility of travel in the existing routes. So, the idea of an option implies a switch will be used, because a switch component provides an optional path. The ambiguity in the question is whether to adjust the clockwise of the counterclockwise path, and where in the layout to make the adjustment. In our solution, we chose to adjust the clockwise path. An obstacle to the desired path in the clockwise direction is the intersection labeled IC4. At IC4, a train traveling in the clockwise direction is routed to a long track section that is not used when the train travels in the counterclockwise direction. However, we do not want to eliminate the merge at IC4, since the intersection is used not only in a route we want to preserve, but also in the counterclockwise travel of the blue engine. So, the solution we arrived at, as you will see in a moment, was to construct an optional or switched bypass to divert a train around the intersection, IC4. Our goal was to provide an optional, more symmetric loop route for the blue engine. By installing a switch track component, the blue engine can either use the existing asymmetric loop route or a new, more symmetric loop route. We replaced a straight section situated before the IC4 intersection with a switch component so that the blue engine will encounter the switch before the intersection when traveling in the clockwise loop route. When the switch is set for the straight path, the blue train, traveling clockwise, will cross the IC4 intersection as in the previous, original version of this layout. We are ignoring the change at intersection IC4 for the present time, since that change was not required for the clockwise path and does not impact the clockwise path. However, when the switch is set for the curved path, as shown in the photo, the blue train, traveling clockwise, will avoid or bypass the IC4 intersection. Next, we replaced a straight track situated above and beyond the IC4 intersection with a merged track labeled 1B. This merged track creates a connection point for the updated clockwise path labeled bypass 1, arriving from a switch. The merge connection allows the blue train, traveling clockwise, to return to the same track that it uses when the train travels in the counterclockwise direction. The blue train in the new clockwise path will bypass intersection IC4 and arrive on the same track as the clockwise travel at the merge 1B. This bypass track provides a path for the clockwise travel route to merge into the path of the counterclockwise route and improves the overall symmetry. While the bypass 1 path is not part of the counterclockwise path, the path from intersection 1B to the switch at 1A exists in both the clockwise and the counterclockwise routes, so we have greatly increased the reversible path length. In the video clip, we are watching both trains traveling clockwise routes. Since the switch is set to curve, the blue engine is traveling the new clockwise loop route, using mostly the same track used when the train traveled the counterclockwise loop route. The blue engine's new route is almost symmetric and reversible everywhere except within the relatively short bypass 1. The route of the red engine is unchanged, and the red engine clockwise travel is still on the same track as it is in the counterclockwise travel. The clockwise route update required replacement of 2 straight sections, one before and one after the straight path, through intersection IC4. The first replacement installed a switch labeled 1A that created a bypass of intersection IC4. The second replacement installed a merge section labeled 1B to permit the blue train to enter the desired track after traveling across the bypass. The bypass required only a few track sections between the exit switch and the entrance merge. You may have noticed another change, and perhaps you are asking, why was Bypass 2 constructed? In the process of improving the blue engine's clockwise route, we unfortunately created a potential issue in the blue engine's original counterclockwise route. In the left photo, we see the curved track located at the bottom entrance of the merge at IC4. When the blue engine travels the counterclockwise route, after passing intersection IC4, the blue train exits the merge entrance below IC4 and takes the curved path that leads into an exit of the switch. When the switchblade is not pointing at the switch straight exit, it is not safe for a train to enter that exit and is not a legitimate travel path. To eliminate an incoming path from entering the straight exit of the switch, we changed the curved section into a merge track, thus creating an inverse curve crossing, as we can see in the photo on the right. The inverse curve crossing removes the curved track, and by means of the crossing, changes the path of the counterclockwise blue engine. Now, a blue engine traveling counterclockwise from the straight entrance above IC4 proceeds to exit at the new straight entrance below. In the photo taken after the change, seen on the right, when we look below the new intersection, we see the straight entrance below the crossing. The newly added straight entrance is now the exit from the straight path above and the entrance for the new Bypass 2. The first section of Bypass 2 can be seen at the bottom right of the photo on the right. The new Bypass 2 provides a path around the switch, which is taken by the blue engine when traveling counterclockwise. This curve entrance at the top left of the crossing of IC4 is used one way, as an exit for clockwise travel for a train arriving from the straight point switch exit. Without a bypass, the blue engine traveling counterclockwise would cross the intersection IC4, take a curved track beyond the intersection, and enter the straight exit of the new switch. The switchblade might be pointed to the curve exit for the clockwise route, which does not support an incoming train at the straight exit. To eliminate the potential problem in the counterclockwise route created when we installed the switch, a second update was installed. To avoid entering the switch exit in the counterclockwise route, Bypass 2 was constructed. Bypass 2 required the installation of 2 new merge track components. We replaced the long curved track connected to the IC4 merge track exit with an inverse curve in a merge section. This change creates a new inverse merge crossing at IC4, similar to those at IC1, IC2, and IC3. The blue engine traveling counterclockwise direction will pass straight across the inverse merge crossing at IC4, entering and exiting the intersection at the straight entrances. This path causes the blue engine to enter bypass 2 and avoid traveling through the switch, instead merging into the path beyond it. Bypass 2 is normally only traveled in the counterclockwise route. Nonetheless, Bypass 2 is a reversible bidirectional track, so the engine can travel on it clockwise as well. In this video clip, both trains are traveling counterclockwise. The counterclockwise travel of the blue engine demonstrates how the inverse merge crossing at intersection IC4 is now supporting both clockwise and counterclockwise routes. When the blue engine is traveling counterclockwise, the switch setting does not matter, since the inverse merge will divert the engine into bypass 2. After bypass 2 is traversed, the blue engine follows the path along the bottom, taking the straight exits at the two merges, ME1 and ME2. After ME2, traveling to the right, the path of the blue engine enters a stretch curve at the far right of the layout, turning upward across a 45-degree level crossing and eventually curving left. After curving left, the blue engine travels a forward merge to cross the intersection labeled IC5. Continuing past IC5, the blue engine passes straight through inverse merge crossings IC3, then IC2, in that order. Both IC3 and IC2 are crossed in the straight path, as the train travels a straight section at the top of the route. The red engine crosses the path of the blue engine at IC2, but the two engines also cross paths at the 45-degree level crossing at the far right side of the layout. At the left end of the straight section after IC3, the route of the blue engine takes a 90-degree left curve, then another straight section, toward the straight exit of the reverse merge labeled 1B. After passing straight through the reverse merge, the train travels into the inverse merge crossing IC4, also taking the straight path through that crossing. So, the blue engine counterclockwise route uses 3 inverse merge crossings, all at the straight path. The blue engine arrives again at bypass 2, which causes the engine to complete this loop route after the merge at 2B. Our analysis of the reverse merge behavior is now complete, and we have demonstrated how the reverse merge is used in layout design. Unable to not explore another possible solution, we continued to make another improvement to the layout. We realized that although we updated the clockwise route of the blue engine to provide an optional new path, we could also have updated the counterclockwise route in the same way. In Part 4, we will change the layout so that there are 2 optional counterclockwise routes available for the blue engine, in addition to the 2 optional routes available in the clockwise direction. The changes required for the next implementation were more complicated than we envisioned at the outset. We managed to add the new optional path while preserving original routes, but the new routes and the updated layout design may surprise you. We hope you will join us again to watch the final segment in our episode called The Reverse Merge Part 4, Star Cross Constellation. Thank you once again for watching and liking these videos, and for subscribing to the channel. The information presented in this video is an honest representation of an actual wooden track layout using battery-operated toy trains. These videos are intended for entertainment and the enjoyment of hobbyists and enthusiasts. The train layout design and construction are our own and are provided without financial incentive. We share these videos on YouTube for own satisfaction. We welcome constructive and polite feedback.